Okay, here we are with the last example of section 4.3. So this is an application problem or applied problem, a vibrating spring without damping. So remember, the damping was the term that included damping was the by prime term in the equation of the spring mass system that we developed. So the equation was my double prime plus by prime plus ky is equal to 0. And so if b is 0, it means there is no damping there. So our equation then simplifies to this. Now the question is saying that if m is equal to 10 and k is 250, and then these are the original or initial conditions, find the equation of the motion. So we start by just plugging in the values and going from there. So we get 10y double prime plus 250y is equal to 0. And these are the initial conditions. And so we write our auxiliary equation, and that gives us 10r square plus 250 is equal to 0, which gives us the roots of the equation. R is equal to plus minus 5i. So you notice here that a is 0 and b is 5. So we write our general solution. So it will be c1 cosine of 5t plus c2 sine of 5t, because a is 0, so the part e to the at is 1. Now I differentiated here. Now there is no product rule here because we have only one term here and one term here. So you get the derivative. Now plug in the initial conditions. We end up getting c1 is equal to 0.3, and then from the second condition we get c2 is equal to 0.1 over 5, negative 0.1 over 5. So which gives us negative 0.02. So the condition for the equation for this system is this one. Now the next part is asking how many seconds will the mass in part A cross the equilibrium position. So what are they asking? What do they mean by that? So this is how it works. So if you have the mass attached to the spring, let's say it's here, maybe it's sitting on a surface. So this let's say the equilibrium position. So if you just leave it, don't like move it or touch it, so it's sitting here in the equilibrium position. Okay, so at this position we said that y is equal to 0. Now if you pick the spring and move it to the right, so the springs will open up, and now the mass, so it has been displaced from this was the original position, now it has been displaced by y units to the right. So on the right we take positive and the left will be negative distance. So what will happen now, the spring, all the forces of the spring will try to push it back towards this side, so it will pass through the equilibrium position. That will be the first time it passes through the equilibrium position. Okay, once it is pushed that way, it won't just stop at the equilibrium position, but because of the momentum, it will keep going to the left, and it could be that the mass ends up coming over here. So what will happen to the spring now? Spring gets a little bit squished. It compressed or squished. So now it could be looking like this. Okay, so then it will, now when it is squished here, now the force of the spring will push the mass towards the right. So it will push the mass towards the right, and then it will pass again through the equilibrium position. Then once it got to the right, then step 2 will be repeated, or step 1 will be repeated. So this I call it 0 step. This is 1 step, 2nd step, and so on. So it will keep passing through equilibrium position until it just sits down or it stops. So there can be more than one times it passes through the equilibrium position, but we will just consider or find out the first time it passes through the equilibrium position. So what do we say? Well, you should know that at equilibrium position the displacement or the distance is 0. So it means the y is equal to 0. So set y equal to 0. So set this function equal to 0. That's what I did here. And now how do we solve this, or how do we solve problems like this? So whenever you have a situation like this, that you have a times sine of b t or b is equal to sine of x is equal to b times cosine of x, or plus minus, doesn't matter. So you can divide by cosine on both sides. So you get a times sine of x over cosine of x is equal to plus minus b times 1. And now divide by a. So, and this thing is your tangent. So equation changes to tangent of x is equal to plus minus b over a. And now you can do it by looking at finding the inverse tan. So we got up to here. We had this equation and we divided by cosine of 5t. Sine of 5t over cosine of 5t is tangent of 5t. So I end up getting tangent of 5t equal to 0.3 over 0.02, and which gives me tangent of 5t is equal to 15. So this is giving me the value 15. And now if you will consider this as theta, so if you have tangent of theta is equal to a number, you say that theta is equal to arc tangent of that number on the right, which is giving me this value. Now, for the first time, and actually what will happen is that when we have theta equal to arc tangent of a number, something b over a. So what happens here is that you get the and you could have even plus minus. So when you plug this number in the calculator, it will give you only one value. That will be the value that first time the mass will pass through its equilibrium position. But what about the other values? How do we get those? For that, you have to say this is plus n pi. And why n pi? Because the period of tangent is pi, unlike cosine and sine, whose period is 2 pi. So when it's first time sitting on the first time it passes through the equilibrium position, then at that time n is 0. So when we are talking about time, n can only have values 0, 1, 2, so on. So when n is 0, that is the first time it will pass through its equilibrium position. N is equal to 1 means second time, n is equal to 2 means third time, and so on. So when we get here 5 of t is equal to 1.5, we can just take it 1.5. So actually what we are getting is 1.5 plus n pi. So when n is 0, 5 of t is equal to 1.5, which implies t is equal to 1.5 over 5, which is equal to 0.3. So it will cross the equilibrium position after about 0.3 seconds. Now if someone asks you after how many seconds will it cross the equilibrium position for the second time, so for the second time you will say n is equal to 1, so it will be 5t is equal to 1.5 plus 1 pi. So plus pi, which means 1.5 plus 3.14, and then you add that, so you get what, 4.64. Then you find the tangent inverse of that, and then it's also tangent of. So now we will find the t, which will be 4.64 divided by 5. So which is 4.64 divided by 5. Oh. Okay, so this says 0.928. So you can say 0.923 seconds after 0.93 seconds. And similarly now for the third time, so n is equal to 2, and then you will have 5t is equal to 1.5 plus 2 pi, and then you will divide by 5 after adding them. That's how you get this. Okay, so that is the end of section 4.3.